Друзья, всем привет! Сегодня мой дилемма. Очень красивый самолет. Yeah, I've been watching way too much Eagle Nagoda the last few years. It's starting to wear off on me. But anyway, this is the next project. It's a plane, obviously. A beautiful plane, as I just said, hopefully. And yeah, I've been thinking about making another large plane for a while. And what I wanted to do was take the power system from Big Red, which was flying about 2.6 meter wingspan, roughly 10 kilos or just under 10 kilos plane, fairly comfortably. But I wanted to do it again with the better construction techniques that I can do now with fiberglass and foam and yeah, fiberglass and carbon fiber and stuff like that. So this is what we have here. It's obviously beautiful, as I said, and it's going to be somewhat of a cargo plane, hopefully. So the Big Red was 9.5 kilos or something just to fly, but what I'm hoping for ambitiously is to make this about 5 kilos just to fly, and then to carry 5 kilos payload. So that's pretty unlikely to happen, so it's mostly just sort of a lofty goal to shoot for rather than something that I'm actually expecting to happen. But as you can see, it's roughly the same sort of style as Big Red, twin, and wingspan's going to be 3 meters. Length of the fuselage there is 1.9, I think, so it's getting to the point where I wouldn't be able to put it in my car very easily unless I break it in the middle here. And this point here is also going to be where the payload gets entered or inserted. So you'll have a normal battery access point in the nose here, but it's not really going to be big enough to put the payload in, because in addition to making it carry hopefully a fairly heavy payload, what I wanted to try and do is make it so that the payload can be a decent size as well. And if I just, let's see if I can hide these. This is the thing about, I'm using Onshape here, it's a little bit slow sometimes. Let's see, you can hide things like this as well, I think. Alright, let me just hide a bunch of these things and show you what I mean about, yeah, and see how it's trying to catch up with what I'm doing. I really did like Onshape for a while, but then I realized it was because I was only using it in the middle of the night when the when my internet is fast, and in the daytime when my internet's not so fast, it's not quite so pleasant to use. And after that, I started using Fusion 360, which I have to say is extremely pleasant to use. There's a funny thing about Fusion 360 is, of all the CAD programs I've used, it's the only one that has the knack for figuring out what I'm trying to do and just do it. It's almost like it's sitting there going, oh, I see, you're trying to do this, okay, got it, there you go. And I'm like, oh yeah, that's exactly what I was trying to do, thanks. But I didn't really get that so much with, definitely not with FreeCAD, and not quite so much with Onshape either. Anyway, this is the back where the payload will go in. Let's look at that in perspective. It's a little bit easier. Is it easier to see? I like looking at it in perspective, but when you're designing, it's not quite so useful. Anyway, so the idea is that there's going to be a massive big 15 by 15 by 45 centimeter empty space right in the location where you want to make it the strongest. And the reason it's there is because that means that the payload will be centered on the CG. So whether the payload is there or not, and how much the payload weighs, doesn't really matter. As long as you put the payload in the middle of this cavity, it should be fine for the CG positioning. Yeah, but that makes various things quite difficult for making it strong enough and impact from landings and stuff. But I think I can work around that alright. By the way, this landing gear is not going to be there. I just made that mainly as a just sort of a exercise in using Onshape and seeing if I could do it. Mostly what this plane is going to be intended to do is actually belly landing, and that's why, let's put all this back on. That's why it has this fin here at the back, like the mini talons, so that when you land, this will help take some of the load and also grab the ground a bit so that it keeps it straight while it's landing, and it doesn't slide and spin sideways like that and hit one of the wingtips in the ground. So yeah, this front sections here is going to be all nice and smooth and strong, and as for the wheels, I was thinking to make a dolly to launch it from, but that would be good for long distance flights and keeping it smooth and clean and aerodynamic. But if you wanted to do lots of landing and takeoffs, as I will be doing when I'm first making the plane and testing it, it would be kind of annoying to have to belly land it all the time, I think. And the other thing is that if you wanted to put a camera on this, which would be quite a useful thing to do if instead of having a payload, you just replaced your payload with battery. So optimistically, let's say we could carry 5 kilos of battery and a camera. Then it could fly for a long time. I'm all very optimistic at this point. I don't know if any of this will happen, but let's be optimistic. And in that case, you'd want to have a camera on the bottom, probably. And if you don't have landing gear, then putting a camera on the bottom is not going to work out too well for your belly landing. You could stick it maybe on the front of the nose, but that's not very good because you can't see directly downwards. But a plane this size should carry a camera with a gimbal on it, ideally, not just a little nose camera for FPV flying. Anyway, I think I've waffled on enough about this for now. I'll just show you the construction as much as I've done it so far. I haven't actually done that much, really. I've mostly been focusing on getting the hang of Fusion 360 and using my new CNC machine and figuring out the best ways to machine XPS foam. And at this point, to be honest, the only thing I've actually started to glue together is the spar. I've cut lots of pieces mostly for the fuselage, but it's all just still sitting in pieces. So this is going to be a pretty big project, and we're not going to see anything flying in this video, that's for sure. But anyway, I'll just show you what I have for now because it's starting to take up space on my hard drive, and I don't like it when I have a whole lot of videos sitting around that might disappear if I have a hard drive crash or something like that. The first thing I wanted to do was make the spar and check that it was going to be strong enough before going any further with that design. So I used this 60 by 10 millimeter pine just from a hardware store, nothing special. Although I did spend quite a while at the hardware store inspecting just about every piece of this to find the ones with the nicest, most uniform grain, to the point where the staff at the shop were probably thinking, what the hell is that guy doing? Unfortunately, the 10mm thickness was still too thick for what I wanted, so I had to start by making this a little bit thinner. So those weigh about 180 grams, and the estimate on shape was 171 grams. So it's pretty close. So when these two sides of the spar get glued together with the foam in between, we want to make sure that they're exactly in the same position. So I made these couple of little tuning forks, which actually, oops, I don't know if you can. They do actually make quite a nice ringing sound if you tap them just right, but they are going to go in there like that, through to the other side. A couple of carbon tubes in there, and then another tuning fork down here. And that should make everything line up quite nicely, I think. So the plan is to put a piece of carbon tow along the top edge and the bottom edge of each of these. This is the inside at the moment, and it'll also go on the outside, but I'm not doing that today. And then the foam will go in between them, and I'm just going to use the epoxy to glue this to there as well. Gorilla Glue I think would be a little bit more suitable, but if I do it this way then I don't need to use peel ply and then do a separate job next time with the Gorilla Glue, so I'll just do it all now. And I've used the CNC ball nose mill. I just turned it on and slid this underneath it manually to cut a nice groove and then sanded it. And this is going to be for the electronics wiring. And when this is closed like that, the other side of this channel is going to be against these, and it would be a nightmare to try and slide wires down with these bits here because it would keep catching. So on the inside of that channel I'm just going to put some sellotape over there so that the wires don't fall into those gaps, hopefully. Right, so that's 20. That's about as far as I want to go with it like this, because I want to put some glass along here as well. And the main reason I'm putting glass along here is to cover up these holes so that when I stick the foam on, it will have a lot more surface area to adhere to. But I'm just realizing that what I should have done is instead of drilling these holes all the way through, I could have just left a thin piece on here so that what I'm doing now wouldn't be a problem. So I realized that I didn't have enough glass to cover this in the way that I wanted to, like going almost all the way across in one single piece of glass. And instead of buying it piecemeal like I have been in the past in those little plastic packets, I thought it was time that I graduated to buying it, you know, by the roll like this, because it kind of looks like as things go forward I will eventually be using it for something or other. I just did a test now with this fishing scale, goes up to 45 kilos, I hope, that's what it says it does anyway. And I put 20 kilos on right on here, just there where you can see it squashed down a bit. It's amazing how resistant to compression this foam is. It doesn't look like it even, like on this side it probably got as far as the wood and stopped, but on this side here I don't think it even got to the wood. It's just the foam was able to resist that 20 kilos load. That was just with a couple of half-inch dowels on there. But anyway, so with the 20 kilos on that single point there, and the other ends were just supported by single points as well, it didn't even creak or make any noises that made me scared that it was going to break. It did bend a bit, but what that tells us is that so it can support 20 kilos there, which is going to be twice the weight of the plane. So you might think, well, that's a 2G load, but it's a little bit better than that actually, because the wing itself, you can't really count that in the weight of the plane, because it's not really, I mean, the wing's supporting itself, but it's not part of that total weight that's being supported at that point, because the mass of the wing is out here, right? A little bit hard to explain, but so it's a little bit better than a 2G loading that we've got at this point, and it didn't like creak or make any scary noises or anything. So I think I'm just going to skip this step and just take my chances with how well the foam sticks to here. Oh, the other thing is that I want to glue some pieces on here for joining the outboard part of the wing, and I'd like that to be a wood to wood connection with wood glue on there, rather than having to glue the wood socket, I guess you'd call it, that goes on here. I don't really want to have to glue that over the glass again. It would be nice if it would just be wood onto wood, so that's another reason that I'd just like to leave this as it is. After that, I started into what was to be many double-sided foam machining operations. So just look at some photos of that. This is where the planing bit plunges straight down into the material instead of spiraling, and that seems to be not very good because the center of the planing bit at the bottom doesn't have any cutting surface. It's just a sort of a round knob, and that rubs on the foam and melts, and then the foam forms into a bit of a lump, and then it slides across like that before it sort of breaks off or cools down or whatever. And you end up with these trails, which, I mean, it's a roughing operation, so it's not a big deal, but just it's not very suitable for that kind of plunging. This is the inside of the fuselage. This is the largest piece I did, and it was sized just to fit inside my machine's working area, which is the black line around there. And that's the same piece there. And I decided to try roughing with a 6mm flat end mill like this, and obviously it's not going to be as fast. But one thing that's really nice about this is it can go much deeper than the planing bit can. And so when I'm doing a size or a 5cm thickness like this, this can go all the way down to the bottom. And in many ways that helps out quite a lot. And it also makes it a much smoother finish on the surface. So you can see here on the right hand side was the 1-inch planing bit, and then on the left hand side is the 6mm flat end mill. This is the outside of the fuselage in the roughing step. So this is my revised method for making control surfaces and hinges after getting to know Fusion 360 a bit more. Firstly, you put them both together with just a small gap there so that you're not wasting so much foam, because I noticed that compared to hot wire cutting, you go through quite a bit more foam like this, because you've got to have, well, this is a bad case because it's not very rectangular, but you've got to have these pin placements here to flip it over. Anyway, so that's cut out there, turned out quite nice. And to make the hinges, we're just going to use those Robart hinges like that, and instead of going directly into the foam, they're going to go into pieces of wood that were also cut, also from Fusion 360, so they're going to go exactly into there, and they're going to be exactly the right size. It's all very nice having a CNC machine to do this. Just glue those in with a bit of Yoo-hoo pour, and then put some of that lightweight putty in there before glassing. You can't see it from here, but on the other side, on this one here, the foam is just left flat, and the idea is that when the glass goes on, this rounded edge will become nice and hard, so you can just wrap some sandpaper over there and rub it up and down to make a nice groove that fits exactly with that piece using the sandpaper. Just getting ready to put the glass on those pieces here. I thought I might show you an example of how the foam differs even in one piece here. So this is one job, so it's the same feeds and speeds, the same tool, just finished with the bull nose. And on the top here, it's about as good as you could expect. It feels really nice and smooth. And on the bottom side, just a couple of inches away, it's all shaggy and rough. It's not as bad as it looks, because you can just sort of rub this with your fingers a bit, and underneath there it was cut properly, so it actually takes a while to get that fuzz off there. But the point is, you just never really can tell if you have a good piece of foam or not. Okay, now starting to line things up just to check how they fit, and I took a bunch of photos here, but I also recorded some video at the time, so I'll just flip through the photos quickly, and you can pause to see them if you want, and then I'll just go straight into the video that I took at the time. Okay, I'm feeling pretty comfortable with the double-sided machining now, and it's nice to be doing it in foam because you can do everything quickly and do lots of jobs to get more experience. So I've done quite a few pieces here, and let me just show you what we have at the moment. Mostly working on the tail because, because I originally started doing that because that's the smallest sort of surface that it has, and then I just sort of working my way down the tail now. And we've done, what have we got here, 1, 2, 3, 4, 5, there should be 6 layers, but I ran out of foam, so there should be one more like that on the bottom there. But that's what we have at this point. 2 pieces in the middle are from 5 centimeter thick foam, and then the ones on the outside are from 3 centimeters. Unfortunately, the color is quite different on those ones there. It's kind of a bummer. Over here we have a rudder, which was machined in a separate job along with the stabilizer together, and this is using my new technique for making a hinge that has no gap, and also no gap when it's rotated as well. If I can just rotate this a bit without, yeah, so when it rotates the gap is still closed, and when you look at it from the end it's kind of like that. And I'm using Robart hinges inside there, and they just slot into pieces of plywood there just to give them something other than just foam to contact. Haven't really seen how that's going to work yet, but I think it will be alright. And then servo is going to go in here, and I have another idea for mounting servos kind of similar to that. There's going to be a piece of plywood in there, and then the servo is going to screw onto the plywood, so you can take the servo in and out rather than using hot glue and that lightweight putty like I've been using. I wanted to make the servos replaceable. Down here we have a piece of plywood in the keel, or the ventral fin, or whatever you want to call this, and that's so that when you land it'll be a little bit more durable. And I'll put lots of fiberglass over there, so it won't be just that piece of plywood that's going to be taking the hit on the ground. The trailing edge here between these 2 sections comes down to almost nothing there. You can see that. And when I was designing this in OpenVSP, I thought, oh, that's a bit ambitious, I probably can't actually make that happen. But with the CNC machine you can. So each one of those pieces there comes down to basically nothing, and then on the other side basically nothing as well. And it's a little bit precarious now. It's at the point where every time I handle it I have to be very careful not to bump that. But when the fiberglass goes on there, that'll be reasonably nice and strong. What else have we got? This is the first piece I started with when I was just trying to figure out double-sided machining in general. And this is the horizontal stabilizer, or half of it. This surface here is all CNC machined as well. And it's the perfect fit to go on here like that. And that should just glue on there quite nicely, I think. I don't think I'm going to use this one actually though, because I covered this with the 100-gram glass and it took up just a bit too much resin and it's a bit too heavy, and also the outcome wasn't that great. You can see there's a fairly large looking seam there. It just doesn't bend around surfaces very well, and then also here on the bottom, and this bit doesn't look very great. And it's heavier than it needs to be, and also the hinges, that's not how the hinges are working in the vertical stabilizer. This was my first idea, and I kind of got halfway through this and I realized I didn't like it that much. Plus, with it being heavy with the 100-gram glass, I just don't think I'm going to use this. So I'm going to machine another one of those later, and obviously one for the right hand side as well, and then I'll make the hinges like I've done for this, because that's going to be much better, I think. Yeah, so this is fiberglass already here, by the way. You can see that. Up here we've got the payload bay. Not too much to say about that. This piece along the bottom was supposed to be a solid piece in the original plans, and Onshape lets you calculate how heavy something's going to be by volume, and it was supposed to be 425 grams. But when I actually bought this plywood and made it, it's like 650 grams. So the plywood was quite a bit heavier than my estimate. And yeah, so that's why I made a whole lot of holes along the bottom here. I can't really do that in the top, because on this top piece here, that is, because that's where the electronics is going to go. So you're going to want to stick your flight controller and stuff on there. I guess some of it could be opened up, but you want to keep at least a decent amount, because you don't really know what you're going to want to stick on there. And this piece here can't really be lightened up too much more, because this has to take quite a lot of load here in this section, and it just slots into the back of the fuselage there with these keyed pieces. Oops, not quite lining up there, but I'll line that all up later on. And if we look down here, we can see all the way down to the tail. It's actually lining up quite nicely, isn't it? So it's all machined out there, so that the walls are fairly thin actually. But what I'm thinking is I'll be able to put some glass along the inside of this as well, and maybe some carbon toe or something, so that when you get the glass on both sides of this, it's going to be quite strong, because it's like this, you know, when you get the glass on both sides, it just becomes really quite tough. So might do that there at least a little bit, but being the tail, I don't want to add too much weight, so I probably won't glass the entire inside surface of this, maybe just about a third of it or a half of it or something. What else was I going to say? Oh yeah, so that the cavity on the inside comes to about here, I think. And so what I'll be doing next is just cutting a little hole for the servo wires to go through. Hang on. Let's break this in half. There we go. Oh, so it comes all the way back to here, yeah. So what we want to do here is dig out a channel to go to about here, so that the elevator servos can come out there, and then also another one pretty much like straight up from there for the rudder servo to go. And then I'll just have to use my hot wire poking thing to melt a hole up in there. Now that the glass is on, there's not so much danger of the hot wire poking thing coming out the side, because the glass itself is not going to melt. For this topmost piece here, I actually machined into the foam the same shape as this plywood strengthening plate, and I thought, oh, that's a bit excessive and fancy, but now that I've done it, it fits in there so snugly and perfectly that I think I might use this in future, just mainly as a method of getting things in the right position. Just helps them line up perfectly. So these pieces here, they are not the only thing that are going to be joining these together, and these keyed bits here are also not the only thing that are going to be creating the right position. So on the side of this here, above there, like that, my first plan was to have a sort of carbon tubes to join them like that. I'm not sure that I'll do that actually. The tube doesn't really connect very well to here, being a circular shape, and it also takes up some room sideways, and we don't have much room sideways to take up. There's only about 3 centimeters there. So I might just use some pieces of wood actually, sort of a pocket piece here, and then a prong that goes in from the other side, and maybe a little bit of carbon toe on the top and bottom of those to strengthen them, and probably go with something like that. And with the CNC it should be easy to make them like a really nice, snug, nicely matching fit, and hopefully that should be strong enough. How to actually fix it in there once, so like you put the tail on and it slides in and everything snugly fits into place. How to fasten it so that it doesn't slide out, I haven't quite thought about that, but it's probably going to end up just with some small screws somewhere. And these holes on the floor of the payload bay, the reason they are so small instead of being made a little bit larger like that was because this is where you're going to want to put things, like your cargo is going to go in there, right? And you're going to want to like slide it down. And if those holes were too large, they might catch on whatever you're trying to put in there. These are actually not too bad as is, but my plan was to put some packing tape over them so that you know, the packing tape would stop your cargo from getting stuck as it slides over these holes. So this is how these sockets and prongs are going to work. The back piece sticks in there like that, and then that load from that strong thick piece gets transferred to the thin plywood, which is a little bit broader, and then that gets transferred to the foam. So it's sort of not the sudden transition from this to the foam is the point of that. And this also helps everything line up together. Then on the inside, you can see on the other one over there, it's like that. You just pull it out like that. And because everything's CNC cut, lines up beautifully. You can see that was all holding together there, but none of it's glued. I can just pull all this apart, and we can see that there's a little bit of a ridge there, which was what was letting it position into those bits. And then unfortunately I didn't have this planned out ahead of time, so I would have used the CNC router to remove that, but I ended up having to do that manually, which took a while, but yeah, not too difficult. So none of this is stuck together either. But yeah, anyway, I think that'll work. And then to make it so that when you stick that in there it stays there, I think I'll have to put another piece across the top here, maybe just around about here, and then a screw into that, and then into this bit to hold it there, I mean just to stop it from sliding out like that. And speaking of pieces that hold together without being glued, we have some more here. The rib there is just pressed onto the end of the spar with those little cutouts, and the engine mount the same. That has those holes like that. I think we might have seen that earlier in this video, maybe, depending on how I've edited things. This is just a placeholder to check that the sizes are right and everything's going to fit together. These parts here will all be carbon fiber, except for this middle one. I think might be a bit okay just to leave that one as plywood. And as it is at the moment, it's a little bit twisty. so it's not going to be very strong versus the torque of the motor. And it remains to be seen whether, when it's carbon fiber, that will be okay. It's definitely wouldn't be any good like it is now. But if it's still not very good, even when it's done in carbon fiber, I'm thinking maybe just using a little bit of carbon tow, maybe glue one end here, and then take it around and back, and then glue the other end there so that it provides tension, and then do another one going the other way as well. Maybe 2 or 4 of them, not really sure. And just leave the carbon tow dry, other than at the ends. Might be something to try, just to provide some tension to stop this from happening. And this piece on the front of the part of the fuselage is not glued on there either. The reason it stays there is because it has these little cutouts like that, or knobs if you like, that fit into here perfectly. And it's really nice having a CNC machine where you can just get everything to line up like that. The wingtip is going to join on to the main part of the wing in kind of the same way that the tail joins onto the fuselage. So this is the spar that goes in the outer section of the wing that's going to be detachable for transporting. And it has a prong on it as well. And again, we have this sort of socket that's going to go on here. And I didn't really make any fancy little knobs on the back to match up this time, because the edge of it matches up. So I'm just going to align it using that, and then this will go in there like that. I have to sand out or file out a little bit here. It needs to go a little bit further, but I don't want to take away this curve here, because that's going to be important for keeping it strong rather than having a stress riser there. So I want the stress riser to be in this rib instead. But anyway, when it goes in there like that, that will give me the correct angle for the tip dihedral that I need. After doing a bunch of machining with this foam, I've decided that the conventional milling direction is actually better than climb milling for this material, at least with a regular end mill like that. So this job here, I'm just part way through it, I've just done the roughing. But this was all done with conventional direction, and the edges are very nice and clean. All looks nice and square and crisp and very smooth. This is a good piece of foam, nice and dense and quite hard. Yeah, and there's just a few little bits of furriness here. So I just ran the vacuum cleaner over this, and these pieces here, the vacuum cleaner couldn't pull them off. But if you do this if I did the same job as I did just before in climb milling, you get these hairy, furry things all over the place, and then you've got to come around with a bit of sandpaper and get them off if you want to get rid of them. The other thing that's nice about the conventional milling is that the chips or the swarf or whatever tends to ball up like that in clumps, kind of like popcorn, and you know, larger pieces. Reminds me of some kind of a tree pollen or something. Some kind of flower off a tree I've seen somewhere in the past. Yeah, but this is kind of nicer than having very, very fine foam. Like if you do it with the climb milling, you get lots of this tiny, tiny little bits like that instead, which is just not quite so preferable for me anyway. Okay, that's going to do it for this part of the build, although like I said at the beginning, nothing has actually been built yet. It's all just parts that have been cut out, ready to be attached together. Well, I did glue. The only place I've used glue was in the spar. The rest of this is just holding together with sellotape at the moment. Oh, I put fiberglass on the tail, rather on the vertical stabilizer, didn't I? Yeah, but I thought I might just upload this now anyway because it's already like a 30-minute video. And sometimes in the comments, one of you nerds has a good idea or a solution about something that I didn't think of. So I might just upload this at this point before I've started gluing, just in case I want to change anything. And I don't know what I would want to change because I've been thinking about this and designing it for a long time, but you don't know what you don't know, right? So yeah, it's a big plane. I didn't think the difference between 2 meters and 3 meters would be so dramatic. These bits here these are just 1/2 inch wood sticks that, yeah, they're 90 centimeters, which is the remainder of the wing that's going to go on there. So they're just the right length to visualize how big it's going to be. And it's a big boy project, as Shreyam said. Anyway, that's going to do it for now. Thanks for watching. Siam paka.